Welcome back to Swift Fundamentals. Today, we will look at loops, which allows us to make actions repeat according to some kind of condition or going through some kind of list. To begin, we could take a look at an array, which we saw in our last lesson. So, let's say we had our array called movies, and let's set that to some movies. Let's say Jurassic Park, and then let's say Up. And then let's say The Matrix. Let's say Beauty and the Beast. Great, so we have this array. Now the way that a for loop can help us here is that it will allow us to get each individual element as we go through the list. So it's called a for loop because we start off with the keyword for. Then we have to say and give a name to the variable that's going to represent each individual element as we move on. What do I mean by that? Well, let's say we're going to say that each element is a movie. And then we have the next keyword called in. So it's called a for in loop or a for loop. And we have to say what list we are going to go through. So in this case, we simply put movies. We open up a code block, and inside this code block, we get to say what to do with each one of this movie or whatever element we've written here as we go through our list. So let's just print the movie. And when we go ahead, we see that it goes through each one. It prints Jurassic Park, then Up, then The Matrix, and then Beauty and the Beast. Now, the key things that we need to keep in mind are the for keyword, which starts the for loop. Then the name here can be anything. Conventionally speaking, we want to make it whatever the singular version of the plural version, right? So in this case, the plural is movies. So the singular is a single movie because we're trying to notate that this is the singular element that we're going to be looking at as we go along. But the computer really has no concern for that. It just needs a name. So we only do that for being able to read your code and making it legible, because I could easily put X here and it would still work. Though now, because there's no such thing as movie, you see that I get an error here saying, hey, there's no such thing as movie. So let's change this to X and see that this still works just as it did before. This name can be anything. So just make sure that you write something that allows the person next to you who reads your code figure out what exactly we're going through. Now, let's go ahead and change this back to movie and set this to movie as well, because I want to make sure that we understand, just like in if-else when we saw code blocks, in for loops, code blocks also matter because the thing that we're going through only exists within this code block. So if I try to write movie out here, you can see that I will get an error because movie, the singular version, doesn't exist outside of this code block, only within the loop. So the first thing is happening here in line 4, then when we go inside, it goes through each one of these in sequential order and doesn't go beyond it. It just does whatever we want with the movie, and then we break out of the loop. Another collection that we can go through is a string, because a string is just a collection of characters. So if we start with var my name and set that equal to a string here, we'll say link. And then we start our for loop, we'll say for. Then we need to write the identifier for our single element. So we can write char for character. Then in, we need to tell it what list we're going to go through. So we can say my name, open our code block, and then simply let's print out each individual letter. And we see here that we get our L, our Y, our N, and our K, each one letter at a time. And do note that inside of the code block, char is being treated as a character and not as a string. So keep that in mind when you start mixing it with another string, for example. So what does that mean? So let's say you have another string here like var my test string, and let's just set that to the letter, I don't know, ty. If we wanted to add each one of these letters, we can say something like, okay, my test string plus equals whatever char is. Then we run this, and then we get the error here saying that we cannot mix a character with a string because, again, Swift is type safe. So we need to change this into a string, and there are two ways we can go about it. We can either write string here and then enclose it in parentheses, and this should work. Though we're not getting any output because we never printed this out. So let's just have a visual representation with my test string being printed out. And you see that it's been added. The other way that we can handle this is, now that we know properties, strings have a property called .description, or rather characters have a property called .description that turns it into a string. So we can write char.description. This isn't something exclusive to loops, but it is something good to know, since when you iterate through a string, you will be dealing with characters. Great, so now we saw what it's like to iterate through a list using a for loop, but it is not the only way we can use this for loop. We don't need specifically a list to execute some kind of for loop. We can also use a range, which we have seen. So let's go ahead and write for. We will use a number for now. Write in. And then we can write in a range, as we saw before, both close or half open. So let's do a close loop, a close range for now. So 0 all the way to 4. Open our code block, and then let's print out what number is. And now we see that this for loop executes the amount of times that exist between the range, right? So it treats 0, 1, 2, 3, 4 as times to go through the loop. It goes through essentially the entire range. This range also could work with a half range, or rather this for loop can also work with a half range. So let's just go ahead and copy and paste this. And this time let's go from 6 to not including 10. And we run this. And we see that we get our 6, 7, 8, and 9, not including the 10 because it's a half open range. Another thing that you may notice is that we do not get that redeclaration error that we get if we use the same variable name. Just to show, if I try using like var and then write my name again and set that to some other variable, if I run this, we see that we get an error here. And that's because these names over here, number, exist only on the code block of the loop. So it doesn't have to worry about redeclaration if it exists in another for loop, because it knows that, okay, this only exists from here to here. And then it can figure out, well, all right, over here, this means a different other kind of number. And so there's no conflicting error there. Now, we pretty much have only printed things inside of our for loop. So let's do something a little more complex. You can also add control flow, for example, inside to handle whatever it is that you're trying to do within this range. So let's say here we can say something like if number is equal to 6, then print out, then print whatever the number is. Otherwise, say print it is not 6. And this is combining our two tools of for loops and control flow to get a specific set of actions, you can say. So we get our 6 here, and then we get our it is not 6 as many times as there are numbers in the range. Now, aside from this if-else control flow that we can use to get specific numbers, another great tool that we have for loops is the where clause. So we can go ahead and write something like for number in 0 through, let's say, 10. And where normally that would be the end of it, now we can add something called the where clause, saying where, and this will do the this will go as many times as the range meets whatever condition we have on the side. So here we can say where number, and if we wanted to print only the even numbers, for example, where number modulo 2 equals 0, and a reminder that modulo means the remainder of the division between number divided by 2, whatever that remainder is. If that's equal to 0, well, only then do we print out the number. And let me just comment the other two for loops so we don't get mixed with them. And let's run this here. And now we see that only the numbers that meet this criteria on the right-hand side of the where statement get printed out. Right? So when it hits 0, it checks this where, and then it executes whatever is inside. Now, we don't necessarily have to print a number. We can easily say like something like, we hit an even number, and we can run this. And we'll see that it happens as many times as the number meets this criteria, right? So 0 meets it, 2 meets it, 4, 6, 8, and 10. But all the other odd numbers, they don't count, so it doesn't go through it 11 times. It just goes through it as many times as it sees an even number. Now, this where clause works with any for loop. It could have worked with our movie for loop, for example, when we're iterating through an actual list. So if I were to write for movie and movies, I could then specify where movie equals specifically up. And only if we see up, then we want to do something where we can like print found an animated movie. And if we run this, we should expect this to only execute once because in our list, there's only one up. And we see that that's the case here. Now, for loops are not the only type of loops that we have. We also have something called a while loop. And essentially what a while loop does is that it looks for a condition, makes sure that it holds true to keep repeating the loop. And then whenever the condition now yields a false, it stops the loop. So for an example, we can write var, let's say number is equal to 0. Then we want to start our while loop. So we hit the keyword while. And now we have to write some kind of condition, some kind of expression that yields a bool that yields a true to begin with to start the loop off. And then we want to change it in a way that it yields a false at some point. So let's say that while the number is less than 10, we want to do something. We will increment number by 1 so that at some point it hits that 10 and then it stops the while loop. So if we run this, nothing happens because we're not printing anything out. But in the background, you can see that this has been executed 10 times. So let's have some sort of visual representation of that. So let's print out what number is. Now, this is a great example here to show you how that number, that the order of code matters. Because here, we're going to have a number at 0 first. It's going to do this check. Then realize that, okay, it's true. So it's going to come into this code block, add 1 to it, and then print out the number. So here, we won't ever see the 0 being printed out because the print statement happens after the increment happens. So if we want to see that 0, we need to move this up here and then run it. And we can now see the 0 get executed because it gets printed. The number gets incremented. It hits the end of the code block. It goes back up to the while loop. At this point, number is now 1. Checks is 1 less than 10. It is. So it goes back in, prints out 1, incremented by 1. Checks if 2 is less than 10, and so on and so forth until it hits 9. It gets printed out. 9 gets added 1 to it. So it turns into 10. And then it checks, hey, is 10 less than 10? It's not. This yields a false, so the while loop ends. Now, of course, since everybody likes to try it, let's go ahead and show you what happens if it eternally hits true. Now here, I've gone ahead and just put a true bool, and I don't change it at any point. So if I run this, this is just going to keep running what is known as an endless loop or an infinite loop. Don't do this. Great. Now that I have force quit my playground and that I am back, we can continue. This is why you really don't want to do these infinite loops. But okay, what else do we have? Along with our while loops, we also have something called a repeat while. So it works similarly with one small caveat. So we have var I, for example, set to 0. And then rather than starting the repeat, rather than starting with the while keyword, we use the repeat keyword. Open brackets. Let's say we print out I. And then let's do something to I. Let's increase it by 1. And then we need to write our while condition. So while I is less than 10. So if we run this, we see that we get our 1 through, or rather our 0 through 9. And the difference here is that in the first example, we see that we have our number and then our first check happens immediately. So 0 gets evaluated if it's less than 10. And then it goes into the whatever the execution is, the actions inside of the code block. But in here, it doesn't do a check. It just immediately does this once, at least once, and then does the check. So I can do something like write this to be 20, and we can run this. And we can see down here that 20 gets printed out once, because even though it's not less than 10, in a repeat while, it will do the actions inside your code block, regardless of your check for the very first time. It'll just go in, do whatever's in here. So 20 gets printed, then it becomes 21, and then it does the check to see if this thing should repeat once more. So since 21 is not less than 10, it stops there. Whereas your while loop does the check from the very beginning to ask whether it should start off to begin with whatever condition you have. Two other tools that we can use in loops is something called a break and a continue. So let's take a look at those. So let's imagine that we have var count set to 0, and then we want to execute this loop while count is less than 10. Then we need to make sure that count is being incremented by 1, since we want to make sure that we don't hit an infinite loop. Now we're going to add an if statement that says that if count is equal to 5, well, then we want to print out if I can write this correctly, we have the 5. And then for everything else, we want to just print out whatever the count is. We can go ahead and run this, and we see that we get the numbers 1, 2, 3, 4, but we have the 5 gets printed out along with the number 5, and that's not what we want. We just want the number. We just want the statement and not the number. So how can we fix this? Now, we could also use control flow by using if else, but since we are inside of a loop, we can use the keyword continue to notify that once we hit that point, rather than continue to the end of the loop, we just continue back up onto the loop and run it again. So what does that look like? Well, we write continue inside, and you see that it's a keyword because it turns pink. And we can run this, and we see now that 5 doesn't get printed out. And this is because when it hits 4, right, it does the greater than 1. Rather, from 3, it goes into 4 here. It does this check, nothing happens. Prints out 4. We go back to the top. 4 gets 1 added onto it, so it turns to 5. The if statement executes. We have our print statement happen. So it, as we see here, and then it sees the keyword continue. So rather than going down and just to the next part as it normally would, it takes its cue from continue and starts all the way on top back to the loop and then executes from there. Now, just like we have continue to continue a loop at a specific point, we also have the keyword break to stop a loop altogether at a specific point. So let's see how that looks. Now let's imagine we have our variable u set to 0. We want to say while u is less than 10, increment u by 1. Let's print out whatever u is. And then we want to check to see if u is equal to 5. Then we want to print out this is the end. And let's go ahead and run this. And we see that we get this is the end after 5, but then 6, 7, 8, 9, and 10 continue. If we were to write continue inside, this would also have the same result, because when it hits the continue, it just goes ahead and goes on continuing with the loop. Now, if we want to stop the loop, we hit the keyword break instead and run this. And we see that even though there's still reason to go ahead and continue the loop because our condition is still true, because of the keyword break, it automatically stops the loop at that point. So it hits 5, it sees the print statement, so it prints it out, and then it sees the keyword break, and it does not go up to check, it just simply stops and it jumps to line 70. So if I had something underneath like print some other code, we see that at that point, it just jumps over to that some other code and executes from 71 onward. Just like we can nest if-else statements in control flow, we can also nest loops, though they work a little different. So let's say we have for I in 0 through, let's say 4, or 3 rather. And then we say for u in 0 through 4. Let's go ahead and print out whatever I is. And then let's also print out whatever u is. Now, because they're integers, let's go ahead and use our description method properties to turn them into strings. Oh, and we're getting an error because we only have 2 dots. We need 3 dots. So we need a space. Later on, when we do a full lesson on strings, we will see how we can simplify this. But for now, let's just write it as so. So we see that our first number is 0 because that's what I is. But then it goes into the other loop and it starts that loop. And so we get 0, 0. So this is I and this is u. Then it goes 0, 1 because u is the one advancing. This inner for loop is the one advancing first. So you go through 1, 2, 3, 4. The loop ends. It goes back to the outer loop. And then this moves over 1. So now we are in number 1. And it goes through the inner loop once again, 0 through 4. As you see over here, 0, 1, 2, 3, 4. It ends. Outer loop moves 1 more forward, goes to 2, and so on and so forth. So when we nest loops, do note that the inner loop will go through its entirety before the outer loop moves forward. Now, something that can help us when we have these nested loops are labels that we can attach to the loops. So for example, we can write outer and then follow that up by a colon, and then write inner and follow that up by a colon. And these names can be anything. So when we want to do some sort of control with like break and continue, we can specify what exactly we're trying to break or continue, which loop. So here, let's say if I is equal to 2, well then we just want to continue the outer loop. So we write outer. Let's run this and see what behavior we get. And we see that once you get to 2, right, the outer one, it goes in here, realizes, okay, I is equal to 2. It says, okay, continue outer. So it does not print out anything here. It just goes up to outer, it moves it over to 3, and we get all the results for 3. Similarly, we can do something like break outer at that point, so that we know we stop the outer loop altogether, and we only get up to this point over here. So very useful tools using labels along with break and continue.